Great. Hello, everyone, and
Hello.
welcome to the Open Meeting 19. Um, Thank you for joining us in our virtual panel tonight. Just a few words on some Chicago Computation Group housekeeping. I just wanted to um, remind everyone that, because we're all virtual, this is going to be, the YouTube live event coming up. And so, given that, any questions that you have, please post them in the chat window during the presentation, and we'll, make sure that we kind of pull them together and ask at the end, or put them together at the end. If you want to get like future updates for different events, make sure that you either subscribe to the channel or sign up on the website that we'll have linked below, just chicagocomputation.com, and you'll get some email alerts. So tonight we have a really special event. It's co-hosted by the Architecture Practice Talks group, and I'll let my co-moderator June introduce that group. But on behalf of the Chicago Computation Group, I just want to say, thanks and introduce the panel discussion tonight. I just want to mention that this has been, this event has been like a discussion that's been in the works now for some time, and I think it'll be a good, start to a series of panels coming forward, which will bring together, firm leadership that's focused on computational design, thought leaders in computational design education, and maybe architects, designers that have since ventured away from architecture into more computational or technology consulting. So for tonight, about half of the discussion or half of the time tonight will be, given up to the panelists, giving a little brief introduction to their background and their career path and a bit of work that they are doing. And then we'll follow it up with a moderated discussion with the entire panel, which I hope will get a little lively with these questions in the chat. So I'm going to hand it over to my co-moderator, June Wang from Gensler, to introduce himself, APT, and the panelists.
Hi, everyone. This is Jun Wang. I'm an associate and architectural designer at Gensler. I just like to say that it was a big honor to be come on to talk at the computational designer meetings. Being a silent follower for quite a long time, it would be nice to actually be an active participant this time. I'd like to just do a very brief introduction about APT, which stands for Architectural Practice Talk. We are a design community celebrating young design talents in architecture, design, and urbanism. We're founded by first by a few Chinese architects working and studying in the U.S., and we're now hosting events in Chicago, New York, and Shanghai. And it's been nice to be able to kind of host this event today with Chicago Computational Group, and so hoping it will be a nice experience. So just let me quickly introduce our panelists today. We have Kyle Vansice from SOM. We have Hiram Rodriguez from ASGG. We have John Morrison from Corgan. And last but not least, Mariel Romero from Perkins&Will. And we have a really nice collection of folks from firms from various sizes. And with that, I would like to push to the panelists to introduce themselves and begin their presentations.
Okay, should I take it from here? Okay, so thanks everyone. Thanks June, thanks Anthony, thanks to the competition group and APT for inviting me. This is like a really important conversation that I rarely get to have, but as computational designers, as designers who have this kind of specialist interest in what is a very generalist field, I think these kinds of conversations, finding mentors, talking to other people who are taking a similar career path is really important in navigating this field. And so I think like the thing that I just want to communicate today is that these personal interests, while they are quite specialist, do find their way and can manifest themselves into projects at a generalist level. And that's in my bio, I always kind of say like conceptually driven work that kind of works at the intersection of technology and interdisciplinary practice. And, those kind of more technical or specialist focused ideas really driving conceptual work. So as the title says, sorry, I think can you see my screen? Sorry, for some reason it tripped. Can you see it now? Okay, sorry, I just had to restart PowerPoint there. So without saying any more, I'll just get into how I ended up at SOM Chicago. So I grew up and I started school at Iowa State University as a construction engineer. I went through my undergrad as a construction engineering student and then got a graduate degree in structural engineering as well as architecture. So I kind of just walked between three buildings for quite a few years, learning a very interdisciplinary way of looking at architecture. Then I went to Foster in New York, interned there for a bit. I also lived in Hawaii for a little bit of time. It was quite fun. And after all of that, about 5 years ago, I moved to Chicago and started work at SOM. But while I was in grad school, I was really into Levius Woods, and there was a really important paragraph that stuck out to me that I think still defines the way I approach work. And I'll just read it. In today's world, which is under tremendous pressures of change, a vital and growing society not only tolerates but actively supports experimentation as the only way to transform the difficulties created by change into creative opportunities to enhance and deepen human experience. This is doubly true for the field of architecture, which, charged with continuously remaking the world, is at the forefront of this struggle. So experimentation and material practice, that's where we're going. My kind of formative project was a studio project with a number of other colleagues, my final year of grad school, for a music festival in Des Moines, Iowa, 8035. Maybe some of you have been. But it was my first foray into, we'll say, complex geometry meets what we hoped would be a deeper human experience of a built project. And then, again, it was just this sort of sinusoidal canopy that was a bunch of things at once. It was a TV screen. It was a bench. It was this kind of incubator of color and light in the middle of this music festival, or just outside. And what I really learned was how you brought a lot of complex ideas together at once, and also kind of started this journey of trying to link geometry and fabrication together. In this context, it was quite low tech. It was a 3-axis CNC mill that we were importing panels into, or cutting off of grasshopper outputs of panelization of a complex structure. And Shelby Doyle, I just shout out. She was kind of my first mentor in this field. But from this project, I learned a lot, and I think that defined my career. Like, this project changed me and defined my career. And we flooded the studio so we get really beautiful videos of this, and got in trouble for that and whatever. But yeah, it was quite beautiful, quite fun. Looking back on it now, there was a kind of can-doism that allowed us to figure out how to do things on the fly that I think sometimes we're missing in current practice. But anyhow, my combining this passion with my structural engineering background and some of the people that I was working with, like Neil Katz and Bill Baker at SOM, I really developed a love for what we call classically smart structures. So not classicism, but structures that were beautiful out of necessity. So here we have the Bath Abbey at King's College. I'm sure everyone here has seen this project, but it's beautiful because it needs to be. It's thin, it fans out where the forces align, and the middle of the structure, I think, is something like 2 centimeters thick. So it's this kind of expressive quality of force flow and the kind of relationship between that and fabrication and again, geometry that has really, I'll just keep saying it, defined my career. And we'll get into what that means at SOM here as we move forward. But yeah, as I said, about 5 years ago, I joined SOM. The first big project I worked on was a super tall tower in Xi'an, China. And the big challenge here was to create a more opaque tall building. An opaque tall building at this scale is extremely difficult, and to do so in a way that resonated with the local culture, which I don't know if anyone here, I'm sure lots of people are here familiar with Xi'an. It's the ancestral home in some ways of China, and it's a bit in the desert, and heaviness and opacity and a kind of desert architecture is prominent and important in Xi'an. So this meant engaging the structure with the exterior wall, and that created a lot of complexity. And it also meant leveraging some of the initial ideas that we developed or that I developed in the pavilion, and alongside learning a lot from at SOM, how to optimize and balance all the competing goals and priorities in a tall building. And that expressive quality in these four corners that you saw really hit a kind of crescendo at these moments of load transfer between the core and the exterior wall, called outrigger zones. And these were also kind of occupied spaces that were quite beautiful and momentous. It's this point of extreme gravitational change in the building, and we really wanted to express that. So that kind of interest has made its way into projects. It's also made its way into collaborations with universities. This is the second year we've done a studio with the University of Michigan. We call it Topology Plus. It's with Wes McGee and Tien, who I'm sure lots of people here have taken a course or two from them, are familiar with their work. But the interest turned into a desire to link up with other people that had similar interests and to create a studio where we were trying to apply these ideas at scale in what we might call like building demonstrators or kind of construction prototypes of digital form finding meeting digital fabrication. And so, here's an example of an early workshop we did with them, where we were carving foam to understand how to maybe more intelligently monolithically cast concrete. And so two different ways of approaching that, left and right. And that sort of manifests itself in a project that we did for the 2018 Chicago Biennial. 2019 Chicago Biennial, called Stereoform Slab. And it was really an expression of the conventional, or an exploration of the conventional concrete slab, which is one of the most ubiquitous horizontal planes you'll see in the city, but also maybe the biggest carbon hog, we'll say, and taking something that is seen as conventional and trying to optimize and make it fun and expressive and to make an impact in the city at a large scale because of that. So all these different explorations in collaboration with contractors and fabricators to figure out what the sweet spot was for conventional concrete construction in Chicago led us to the smart band beam. And it was also something that a lot of the colleagues at SOM had been working on for a long time. Benton Johnson is a good example of that. And again, Bill Baker. And then here it is. I'm sure I hope some of you have seen this, but it was a prototype. They had a prototype in space, and it was done using robotically carved, we'll say, stereotomy is what we call it, but robotically carved formwork that could be done very quickly, fast form making, and used a ruled surface, which was really the expression of that craft method, that we sort of synthesized with an optimal beam shape that reduced the overall carbon emissions or embodied carbon of a typical concrete building by something like 20 to 30%. And we went through the whole process in short time, and I think less than a month, which was really amazing. It was really a kind of great study in how to innovate at scale. And it's quite beautiful because every square inch of what you see here on the screen has a piece of rebar behind it, right? So it's very authentic, it's very honest in its expression, but it's also very sculptural. So it's driven by a need to reduce material, but in doing so, it's quite beautiful in its materialization. And then deploying it at scale, hopefully you can imagine how this would seek to de-homogenize what is a very homogeneous built environment, right? We're sort of stacking concrete plates end on end, top all the way, up to the top of a building, and we're looking for ways to break that down. And this has found its way into other projects that I've worked on. This was the competition for O'Hare, where we're really pushing the roof to be smart, to work as a kind of two-way system, but also to bring light in a very, we'll say, synthetic way with the structure. They were both kind of working together harmoniously, and this would ultimately create a kind of light-filled, beautiful passenger experience. Or a project in Shanghai where we were seeking to express an optimal beam system that really pushed the idea of a heavy horizontal and expressed the intelligence of a structural system in a program that was meant to showcase a broader intelligence around technology in contemporary society. So that's it, and I didn't really talk too much about my daily work at SOM, but I just kind of wanted to show how my interests have manifested themselves into projects, and we can certainly talk later about the kind of details of that. But yeah, that's me.
Sorry. Can you hear now? You're good? Okay. All right. Yeah. Yeah. Okay. Cool. Thank you. Thank you to the computational Chicago group and the APT as well. I think this is a great event for a lot of people to get to know the practice, the folks that are doing some cool, innovative stuff like Kyle and some of the research that's going on, but also to understand the path of the different people have taken to take this route of computational design. So I'm going to talk a little bit about how my path came about and what are the things that have changed my career and some of the people that have changed it and some of the ideas. So I think it's more talkative and more of a words than project specific, because I think it's important to show that. So the first thing that I want to show is the school I went to, Pratt Institute. This is a Brooklyn school. Studied there in New York and Brooklyn, and then went straight into a group called Core Studio. It's a sub R&D group for Thornton Tomasetti. And at the time it was small. It was about 10 folks. But the important thing about this, to know about this group and the people involved, it's a interdisciplinary group. So they're not all engineers, they're architects, they're scientists, they're web developers, GIS. So they have a range of people that have different skills. And I think that was very crucial to the way that I work now and the way I think about the process, the delivery, and how you approach projects. The practice at TT and Core Studio they have about, I don't know, I think they're growing in the amount of services they provide, and you get involved in every single of them for the most part, and you get to know a lot of people, and you get to realize that your skill sets have to change throughout the different phases of your career in there. So you go from computational to web developer to Python to GIS to all those things. So I think those are very critical that I found in my career. And they have translated and go on to help me with the other firms. And what you see there is some other people that I work with that here at SGG. After leaving the company, leading the Core Studio in Chicago, I moved to SGG, and I think the interaction with Gordon and the partners and the sustainability of the building science and the architects is pretty amazing. And I think that's that relationship between people and different practices that make the career and your approach to technology important. So just keep in mind when you're looking for these kinds of practices or these kinds of groups that you find individuals in groups that have a different thinking that you have, or that have different processes, because that's going to change the way you think and how you resolve problems. I think that's what I want to get out of this slide. And one of the cool thing about this slide is a lot of these people have left core studios to start other companies, either startup companies or Hypar, or a lot of have teach in Europe, and WeWork and all these things. So it's a you can always approach core studio and trying to get some folks from there, and if they get your offer, you get a pretty good range of skills and people. So just keep an eye for that group. I'll talk more about them and the process a little bit more. So I want to also put out a couple of things that I think are important that I've seen in my career and in the way that I've worked, the different branches of areas that you would probably have with computational design individuals. And I think it's important to understand that there's where I think there's about 3 different branches. There's the computational designer who is, a couple of years into the practice and has developed workflows, works with teams, creates virtual materials, or goes to present to conferences and has this kind of interaction with the firm, which I'm critical. I went through that. I went through working through different projects, stadiums, high rises, you name it, everything. And I think that's crucial for that. And it's very important for the group to have those people and proceed them and grow them into different positions. The next one is the computation lead. And this is somebody that would lead a company or a group or practice within the firm. And you have support from the firm to produce R&D. You will also have interaction with with clients, and some of those things that I've done in the past is responsive RFPs and have direct connection to managers and staff. And I think that's critical. Some of the things that you've done in the past as a computational designer translate into this other middle part, and you start engaging more and more and more. So it becomes a little more management style, but as well with this kind of like thinking of computation on the back end. And the last one I think is the director of design management kind of person that can hire teams, can have a development team, can have a design technology team. It's not necessarily doing any of the work, but it's managing all these different things, and it's bringing funding to that group and getting tool development to that group and getting work outside of that firm, outside of the core studio, where they were hired just to do development for other companies, right? And that's certainly something that you can do, or the firm can do, if they see that there's a market and then there's a clientele that wants to do it. Maybe it's a feasibility service that you want to provide to the clients. So I think just keep in mind the range of things that you can do and how they change throughout the career. I know a lot of companies have different ways of spending that, but just keeping that in mind. Nobody told me that at the beginning, so finding out those things and having those in mind and sharing that with the community, I think is great. So the other thing that I want to share is that, being a computational designer and being part of these kind of groups and integration to the firm is not just about one single thing, right? Well, the way I see it is that somebody who's going to be leading this kind of group or be part of this must have a range of skill sets that can address different things at different periods of time. And you can engage different groups, clients, and problems. And so if you go back to the early slides that I have, it's about the integration of interdisciplinary group that allows you to create the skills, and then those skills get applied. So I think it's just broaden your knowledge and your skill sets. It will help you a lot. And the last thing that I want to talk about is 4 major things that I think it's critical that I've seen in my career as part of growth. And one of them is doing applied research. Find a company that has a group that's doing applied research. That's going to change the way you see architecture, engineering, construction. We're doing something with zero embodied carbon concrete, with our building sustainability team, our science team. And this is something that we do locally here with the Osinga group. And we have a project that's going to go with LinkedIn. So I think it's crucial to have those kinds of projects and be part of them so you understand what the process is and how you apply them. So it's moving beyond the kind of grasshopper kind of skills to something more applied research. I think Kyle mentioned some of that with the concrete that he was doing. So I think those are pretty cool to be part of and just have a few of them. I think the next one that I would like to talk about is the hackathons. I think the hackathons are crucial. I know at SGG when I went in there, they do them every year, and I think that's very important to have as a development for teams, for people, for careers, because I think it's crucial. I saw that with Course Studio, and you get to participate with a lot of teams, get to know a lot of people, understand somewhat of what the trends are with some of the industries. You'll see a lot of teams coming in with ideas of web development, adding Dynamo things or GIS stuff or connecting to governmental websites for you name it, whatever. And I think it's crucial because then you get exposed to the type of projects, the type of scripting languages, and the type of, I don't know, the way how you think about it in terms of developing and hacking. And I think that's something crucial to understand when you're a computational designer, especially early on. How do you hack things in a sense that how do you make sense? How do you make things, flow from A to B in a way that makes sense? And one of the things that I want to show in this one slide in the top right is that a lot of people, when I was a TT, a lot of these folks that are in the upper management will attend this hackathon. So it's crucial to show them the benefit of what you're doing when you're doing this project, so this hackathon. So we see it at SGG as well. The partners attend, project management attend. So I think it's important, and you get to know people more closely, like Mustafa and some other folks out there. So it's great. The other two things that I'd like to touch is the R&D part. I know a lot of companies don't have R&D and there's no funding for it. I'm lucky to have some of that at SGG, and I've worked with Anthony in some of these projects, and we had a pretty, so far so good, I would say. But I know Course Studio has a pretty aggressive R&D commitment, and it pays off. They build tools, they build things, and they are able to do other things. And I think that's crucial because then you can test applications, you can test them in projects, you can present them, and you can apply them if they are feasible and if they're key. You can see we're doing some Terracotta project. I know Mario was part of that as well, and SOM has been also part of that as well. So I think it's just being part of those kinds of groups and having ideas every year that you can proceed to present to the partners and people in the office to produce R&D. I think it's very crucial. And the last thing is training. So you have all these different things: apply, research, R&D, hackathons. But at the end of the day, the computational group or the whatever group you want to call it, the person who's leading that needs to go back and needs to make sure that the firm has those same skills that you're having. So make sure that you're teaching others how to do it, because at the end of the day, this computational thing is about community. It's about the practice. It's about teaching others how to do it. You don't want to be the same thing. The guy who does it all the time and is just doing the same thing. You want to be able to branch out and proceed to other things. So I think training is a critical thing, and I know we've done training at the office for a lot of things, and we always have McNeil group come in and show us stuff and jump into Rhino inside and do all these different workshops, and you see it right on. People will pick it up and people will see it, and it's part of that kind of effort. So just keep that in mind when you're doing all these different things, that that everything that you do, make sure that goes back to the community that you're serving. That's the firm and that's the projects. So I would say a good computational designer would always give back to the community. So that's it. 10 minutes.
Thanks.
Thanks for having me. I really appreciate being here. So I'm going to jump in. I'm John Morrison. I'm an architect working in Chicago. And that's me 15 years ago. Yeah, so I started out painting. I did my undergrad in scenic design. And right off, I worked freelance for a lot of these small firms doing these art installations. And I wanted to see what it's like. So I must have done like 50 projects those first couple of years. I mean, they were pretty small, like 2 or 3 people in the firm. Projects lasted like 2-3 weeks. And I also had my own company doing these gigs. So I was designing and painting a lot. But it turns out I didn't charge enough money. I was bringing in, I don't know, $10,000 a month, which at the time I thought was pretty good. But after I hired a person, 2 people, I mean, the money was gone. There was no profit. What I did get was perspective, right? So we were doing these movies on real film, and we were doing blueprints on ammonia, right? And we were painting with these aniline dyes. I mean, it was beautiful. It causes cancer. So I saw this transition to the digital. And some of us were messing around with these Mel scripts in Maya. And I realized you could paint with code. And I say this because our knowledge cycles only last a couple of years, and I'm seeing these same patterns. Like paint to Photoshop is the same way people act whenever they go from CAD to AI, you know, and it all repeats, you know, but I see it again and again. But I mean, I remember 2008, you know, I was working with this client and I had an appointment. It was October 2008. And I show up to the front door and there's this orange paper taped to the door and the stock market crashed. And they didn't honor my contract and they went out of business. And I said, forget this, I'm going back to school. So I was working, I went to the Harvard GSD and I focused on computation. So I took some classes in the computer science department. And it's really empowering, you know, you don't have to accept the tool set anymore. You can make your own. I mean, it's a game changer. And I think schools like Stanford have a great computer science department. I could see them pushing ahead because of this. And I think coding is the new literacy. And the language like C# and Python. Like machine learning uses Python and both Rhino and Revit use .NET, C#. So those are the ones that I focus on. And I think there's a long history of architects using the language of mathematics and descriptive geometry in the work. So I don't think it's that big of a leap or radical statement. I mean, you can see it that, you know, code is everywhere. So when I was working in the geometry lab at Harvard, we would use these math formulas. And I programmed this plugin to read MathCAD into Rhino, and it's called SurfTM. The interface was pretty simple, right? But inside of this one component was all this code, you know, just under the hood. And I worked with Panagiotis Pigalatos. He's the developer of Millipede. And we made this physics solver, which is kind of like Kangaroo, but it was a custom solver. And so I did these simulations, right? A lot of Fry Auto's work. And we were really into it. And Fry Auto won the Pritzker the next year. Yeah, I could see why, you know, the work, it felt really relevant, but simple, you know, just digitize a cool idea. And I mean, I wasn't Mark Zuckerberg, but I coded this project for my final studio. It's a combination of some of these ideas. And right after the presentation, you know, Patrick Schumacher came up to me and he offered me a business card and he said, we'd love to have you in London. So I went. And Zaha had 9 studios in London and each one had its own personality. I mean, there was the loud one that threw candy at each other, and then the quiet one where everyone wore headphones. And there was a dedicated code research group. And it was a lot like a lot of little offices inside of one big office. And Zaha was the gatekeeper. It was so tough to get her to sign off on anything. I mean, if you could get it, then you didn't want to go back and try again. Like, the project would just run out of money. And the engineer comes in and he says, I love it. The design never changes. But inside, it was a totally different story. I mean, it was the most dynamic workplace. I worked in 7 of these 9 studios, and they would shift me around, right? Turnover was pretty high. And I tried to soak it in because it was not a forever job. So I was doing these amazing, exhausting projects and using computation like all day. And I had way too much work to do. And instead of panic, you know, it was a relief. Because I was coding, I was doing this stuff that exactly what I studied in school. This one here. I took this car park that Zaha did in the 90s, right? And she played with projection. And I did the variation. So this is a hotel in Rome, right? It's from the 1600s. It's across from Campidoglio. And I bent the projection with computation. And we get this interesting and subtle floor pattern. And Zaha got to see it before she died. And I feel like it's just that one thing, you know, the transition to the digital. And it was able to add something to one of these themes of her work. And I'm proud of it. I think it's beautiful. And then we packaged it into these mesh back mosaic tiles, and that's it, paint by number. I think the firm did a lot of that. You know, they create their own software instead of using a lot of libraries. And they work mostly in Maya and Rhino. And some people were from a computational background, and others approached it like sculpture. And of course, we always put a lot of polish on it when Zaha came into the office, these big color renderings. You know. But the idea was never look at my code. You know. Coding was a means to an end, and Zaha reacted to the design. But they gave a lot of flexibility, you know, to use whatever tool to get the job done. I think Patrick Schumacher coined the phrase parametric in his book. And at first I thought he meant like the mathematical definition, like independent variables. But then at the end of the day, you know, when you boil it down, maybe parametric just means made on a computer. When Zaha died, I decided to work on these big civic projects. So I worked on London Heathrow Airport and Nashville Airport and Atlanta Airport and JFK Airport. And I was hired as an architect and not a software engineer. So most of my scripts are project-based. But I mean, I code for myself. So if I want to do something like import Matterport XYZ file, you know, or do OpenStreetMaps, you know, or LiDAR scans, you know, I mean, I make a plugin and I mean, I just make it. So I put this into this Corgi plugin, and it's on the Rhino package manager. It's, you know, mostly for myself, but I use this stuff, you know, all the time. So to sum it up, I guess I'd say this has been my strategy. Get registered as an architect, go to a good school, famous internship, and in some way I'm still painting. You know, it's just with a bigger canvas. Thanks.
How about now? Perfect. All right. Sorry about that. So Wow, that was that's really hard to follow up on. So, like very similarly, I think I'm just going to kind of run through really quickly my my trajectory in this kind of space within architecture. So I've broken it down into 3 sections because everybody likes 3. So this is more about me, or at least who I was. So my education is actually both in architecture as well as computer science, specifically at UIC here in Chicago. I actually got started in my career really, really early on through a series of kind of fortunate events in my life. But I started working at Adrian Smith and Gordon Gill Architecture when I was 17, actually. And I worked there for roughly 13 years. So about a year and a half ago was actually the first time that I've stepped outside of, I always consider it like kind of the motherland of myself. So I started as an intern, obviously, because I wasn't like a licensed architect at 17. And I sort of eventually found my way into this kind of nascent role of a design technologist, is what we'd like to call it now. But it was really just something that like I was good at computers, and I was like decent enough in terms of like helping with the design teams that I can like kind of be thrown on a design team and help out, kind of figure some things out, right? So I kind of to that, or in that regard, I kind of integrated myself into most projects that I've worked on as sort of, if you guys aren't aware of the term script kiddie, it's just like, it's kind of a derogatory term used by like actual hackers to like describe little kids that went online and downloaded like code and try to like hack other websites. That's mostly what I was. I was just kind of feeling my way through this territory because again, like I knew that I really, really liked technology, computers, programming, and, you know, also like designing and architecture and kind of the built environment. And I was trying to figure out how I can kind of facilitate these two like loves and desires and kind of mash them together. And for the most part, like for the better part of 10 years, that's all I was doing. I was like mashing them together. There wasn't this kind of beautiful merging of them. Until eventually this is who I am now. I eventually transitioned into the role of an architectural designer, and that's role, ROL. And what that means is just like I was a part of, like I was fully accepted as a kind of design team member. And you know, as like Anthony and Hiram can attest to in that environment, they're kind of Adrian Smith and Gordon Gill Architecture was sort of and still kind of are, they're known as a boutique, like high design firm that focuses primarily on large scale projects, whether they be super tall or like large scale master plans. And a lot of the kind of design practice, essentially the way they kind of viewed it is that computation is part and parcel to kind of the design ethos. And so like however you need to do it, and it's very similar to kind of like Zaha, it's not about the tool. We never cared about the tools. We cared about the kind of resultant output of the design. And so, you know, because of the kind of nature of that design practice, we had to like very quickly rapidly iterate on multiple design schemes in a very meaningful way, right? Like, you know, we had like 10 different, like I would have to design 10 different massing options. Then I would have to facade this thing, have that facade like be some sort of meaningful engagement with the environment around it, and have a reason for its existence, right? And all of this in like the span of like 2 or 3 nights. And you know, in that regard, like kind of the concept of computational design just made sense to me. It made sense to a lot of the designers in that kind of space. And you know, in the broad strokes, like computational design is just kind of like, you know, using the computer to like let you do things that the computer is really good at, which is just like number crunching and iterating initially, right? So, you know, in that regards, to kind of like showcase, I'm just going to show a bunch of pretty pictures right now to show you what I've worked on, I guess, to like lend credence to my to what I'm saying. But this is more about the work that I've done. This is mostly the stuff I've worked on. You know, high-rise skyscraper. I think it's still a confidential project for Adrian Smith and Gordon Gill Architecture. A little bit of this is actually a project that Anthony and I worked on together. This is a bit of a love child of ours. I think it kind of was pretty formative for, at least for me. I don't know if Anthony would chime in and agree with that in the panel, but this was kind of like, honestly, like a huge break for me in regards to like understanding where the the kind of role of technology, computation, architecture, and quite frankly, beauty kind of like started integrating into one like real package of like a final kind of product where, you know, there like the form was like, there was a lot of iterations on the form and how we drove it, a lot of actual kangaroo usage, which is like my first foray into like really programming something. Then it's also kind of like a bunch of iterations on like the facade, like what were we doing in terms of the systems themselves, how we were placing and orienting this thing, what the kind of mechanical systems were like integrated in all this. Like it was just kind of, it was sort of really eye-opening for me, especially because like working with someone like Anthony, who I would say is like kind of like one of the at least for me, one of like the originators of like computational design within the kind of space here, right? Like, or at least his generation is in that capacity. Not saying that you're old, Anthony, just saying. Then I went out to do work on the Asana World Expo in 2017. This is unfortunately not the project that Anthony was heading up on, which is the Sphere. This was known as Congress Center. Also, the Al Wasl like World Congress, or and this was supposed to open up in 2019. Now it's pushed to 2012. This is the center dome that I worked on, actually in conjunction with Thornton Tomasetti's core studio, specifically Eloy Kemp, who's a part of this group, and the Chicago Computation Group. And this is like, you know, a lot of this is, again, the same kind of task of iterating, redesigning, and like leveraging computational design to allow us to kind of very quickly design these things, render them out, view them, see them, and kind of also like do analysis, like to kind of vet the design itself. And that, you know, we'll kind of go a little bit forward with that in terms of what analysis actually means, because a lot of my career has actually taken on the role of a kind of like a computational analyzer, let's say. This is also, this is a project in Wuhan. So it was and still is a very beautiful project. I had an enormous amount of fun working on it. Actually, Anthony started on this, and I like to joke that I finished it. And, you know, ultimately that kind of leads into what I'm doing. So that was my previous work at Adrian, Smith and Gordon Gill Architecture. And these are the tools that I've kind of, that I'm working on now. And I've just been at Perkins&Will for the better part of a year now, maybe a little bit more. And a lot of my work at Perkins&Will, technically my title is Digital Practice Manager and Computational Designer. So I hold two titles, which is really weird, just depends on how I want to use them. But for the most part, my role in the company, and we're an office of 2,800 strong, spread out throughout the world with over 13 offices, very similar to SOM in terms of its size. But we try to like kind of really get into what are the overlaps of computational design and what our designers are actually doing. How can we leverage kind of these like custom tool sets, create them, package them, distribute them, and have them be like fairly easy to use within like kind of the design process, right? This is just like large scale urban analysis for like view corridors and stuff like that. You know, integrating Rhino Inside, which is like, obviously, like that's kind of everybody's doing that. Everybody's saying that it's cool because it quite frankly is, but it's what we're doing is kind of really figuring out how to like very easily deliver this workflow to like our designers so that they can actually do most of their project using this workflow. Because, you know, as we all know, like there's some issues with Revit in regards to how you design, and there's some freedom within Rhino and Maya in regards to how you can design. And so it's kind of merging the better parts of two worlds. As well as, you know, again, writing different tool sets. Like this is just pedestrian simulation, which we rolled up into a kind of package, and everyone in the firm has access to this and can use this and has used this on multiple projects. Same thing for this. This is just like a quick fun little thing, not fun. That's a terrible way to put it, but this was like a social distancing tool that we use for classrooms. Quick and fun in regards to like, it was a pretty like interesting kind of immediate actionable item that we needed to leverage and use as soon as kind of quarantine hit. and then ultimately to being able to like work out pedestrian comfort tools that are custom baked in, you can launch within our kind of Rhino environment, and kind of vet your design or your massings at kind of within a certain like degree of accuracy, and kind of like be confident enough in this kind of analysis that you can start like using these things as design tools, not just kind of post design tools, which I think is the ultimate kind of the Achilles heels to this sort of analytical computational design process, right? Where the design has already happened, somebody's asking you, or you're put in charge of essentially vetting what the design already is. And we've kind of coined this term of just-in-time simulation, where you have these tools, or we're developing and have developed these tools to kind of very quickly and easily integrate it within our design practice, so that you don't run into these issues of like, well, it's already designed, I guess we can't change it anymore. It's already in it's CDs, it's being constructed, and we've just dumped a bunch of money on something that we know won't work or doesn't do the job appropriately. And then section 3 is a very simple one. This is literally just a wall of text, so forgive me. How I've worked specifically in small boutiques, and this is something that like Anthony and I were kind of like working through a little bit or chewing down, but the small boutique was, at least in my framework, Adrian Smith and Gordon Gill architecture, right? I think right now it's about 50 to 55 strong. And a lot of that kind of computational design learning like involved like ad hoc kind of utilization of like these kind of nascent tools, which meant that we were pretty scrappy, right? Like since everyone was kind of expected to at least know these workflows, or at least these processes, like you can fairly easily integrate like the tool set in almost every project. The kind of up and downside to this is that it was very much the Wild West, right? And I think a lot of computational designers can kind of really like understand this, right? Where like it's kind of everyone's doing their own thing. There's no real central repository of information or knowledge. Like Anthony was joking about like making a mullion maker, and like how many times have I made a mullion maker in my like lifetime, right? Like, and that's like because it's like, I know that I can make a mullion maker like in about 5 minutes, but somebody else might need it, and they're stuck for like a day trying to figure out how to do this, or they're manually creating the mullions in Rhino, right, for like a rendering. So like, again, within the kind of small boutique, the expectation was that computational design was part and parcel to the design process, right? Like it was a part of the design process. It wasn't its own kind of separate, unique thing. And in fact, a lot of the conversations that we had with our partners when we were kind of pinning up or showing our work wasn't how you got to this point computationally. It was a design dialogue, which I think is it's very important to note in these smaller kind of boutique firms. And also, disparate knowledge equals flexible but repetitive, right? Again, with this idea of like constantly recreating the mullion maker, because I made one for myself, but there was no central repository for somebody to be able to pick it up, use it, and go. Or, I would remember, hey, 3 competitions ago, I was working with Anthony, and Anthony had made a mullion, or had made me use a mullion maker, so I can go to him and ask him for a copy of his mullion maker, right? So again, that's kind of the downside to this kind of disparate knowledge pool. And then large and global, right? So large global firms like Perkins&Will are organized, logistical. They have a vision and a goal for our computational design practice, right? So I'm part of digital practice. We're our own kind of corporate structure. We're not tied down or like rested within a particular office. We exist as our own separate entity, and one of our only real goals is to make sure that we can deliver things in a kind of sufficient, timely manner, and like kind of the most productive way possible, while still maintaining the kind of design intent, right? Which is always like the kind of line that we parrot, does this meet the design intent? And because of that, we're focused on packageable, repeatable, business model-centric design aids, right? Again, these kind of tool sets or custom workflows that we vet and like break and reconfigure and make it so that almost anyone, or at least our goal is about 85% of our design practice, our design team, to be able to use these tools. And that means that because it's centralized knowledge, it's rigid but accessible, right? And I think that's a big thing with this, is that we have a slew of kind of deliverance pipelines that allow us to kind of, again, vet these tools, break them, reconfigure them, debug them, but deliver them to designers in a kind of centralized way. With all downsides to that, right? Like, it's like, what's the difference between moving or like turning a schooner and turning like a freight or like a cargo? Like, it's like, it's harder, right? But it's doable. And I think that's it. that's my whole presentation.
All the panelists there's a lot of impressive work, I have to say. Oh, here's everyone's faces. All right, so are you guys ready for a round of tough questions? Anthony, do you have anything out of your mind? I see there's already some questions from the audience. We want to start with that, or?
Yeah, I think it actually, was a great introduction to, what you guys do at your individual firms. One of the questions that we have, I think, is maybe preceded by a question that I think, we were talking about, Mario, and it really, maybe speaks to this idea that, there's differences, obviously, in your past. I think what's great about hearing all of your histories is that there's like this dichotomy of like, I worked at, ASUG, I worked at Perkins&Will, or I worked at, I did I did art history and painting, and then I worked at Zaha, and so I think there's this interesting dichotomy. Can you talk a little bit about maybe which one is more or less effective in terms of design innovation, in terms of like, ASGG versus Perkins&Will, or Core Studio, say, versus ASGG? I think, just hearing some of the conversation about different firms is something that I think somebody's asking questions about it, and that's interesting to kick off this discussion.
Yeah, I mean, for me, like, I think I tried to do a little bit of outlining in that specific question, like in terms of like kind of digital innovation. Like, it's kind of a double-edged sword for me, where like I kind of like the Wild West because it meant that you were kind of freer to do what you needed to do to get the job done in regards to like, like effectively at the end of the day, like in a lot of these conversations, like I feel like the latter half of like our terminology is often forgotten, right? We're computational designers, like we are designers, and like I feel like quite frequently the Wild West like behooves kind of, or the like designers are beholden to the Wild West, right? But again, the problem is this kind of disparate knowledge pool. Whereas like the boutique firm allows this kind of rapid iteration and kind of, I think when we were talking initially, I called it like an autoclave, right? Like this small 50-person firm essentially acts as a kind of innovation autoclave. Like the heat will build up, like there will be turmoil, there will, but like through that process, there will be a product that is better for it. But because it is small, it means that it doesn't have, let's say, the capital or the leverage to be able to like directly talk to, let's say, like knowledge experts or like practice experts in regards to computation, like digital innovation, right? So like Perkins&Will has a direct relationship with NVIDIA's AI and ML department. Like I can have a conversation with them quickly and easily because they're interested in what we're doing. I think that's kind of one of the bigger takeaways or one of the bigger advantages that a larger office has. Great.
I would say that one of the things that I've seen is buy-in from upper management and willingness to take the risk makes the difference. I saw that with Core Studio, upper management and CEOs taking the risk for leveraging new technologies and doing so in a way that's feasible for the firm and the team. And also for SGG, I've seen that there's a leverage in there that where you can proceed, you can follow those, making sure that it makes sense it pays off in a way that's both for the office, for the group, and as a whole for the company. So I think innovation, I think it's a little different depending on what the firm vision is and the people who are driving it. And there's ways you can do about it. You can go about it in terms of how much it's going to spend or how much money is going to be funded into it and who you need to reach out to. A lot of these companies, NVIDIA and all these companies, are willing to work with a lot of people. So I think it's what they want is get a perspective of the environment, right? And I think that's something that benefits everybody, because at the end of the day, I hope that everybody can put work out there that it's open source, because at the end of the day, it's for the benefit of all of us. I know John put his package out there. I don't know if he has a GitHub page where it's open source, or some of that code is open source, and I think that's the real benefit, right? I know Core Studio has that, and I hope that SG at one point delivers that process where some of that is open source.
Yeah, it's an interesting question. I hadn't really thought about it too much, but I do think that there is probably a scale, right, between the small boutique firm and the large firm, right? SOM, I think, is kind of in between. I think we're like exactly in the middle of 2050 if you divide it by 2. And it's like as a smaller firm, you probably realize the design potential more than you care about the efficiency of design tools. And as you get bigger, obviously you care about the design potential, but the kind of scales of efficiency that you have to leverage, right, in order to maintain like a certain level of product deliverable, or a certain level of efficiency, we'll say, in the way that you're delivering projects, probably requires you to think more intensely about scaling your computational capabilities, right?
Yeah.
Packaging them up, distributing them to the masses.
Right.
And I guess at small scale, you don't care so much. You just care about the design potentials that it affords.
Yeah. I mean, to kind of touch on that a little bit, I thought that I made like the extreme like shift, right? I went from like small boutique where we generally didn't care about those efficiencies, just because it's like whatever efficiencies you would gain like were negligible, right? Because we're so small, to again this like 2,800 person firm that like even the smallest, most negligible kind of gains in efficiencies meant like a lot of money, and just in terms of sheer volume. Which is like, like if you like figure, like now I'm like thinking, like I'm constantly considering like, if I can save one person one click in Revit a day, like, or like one person one less sync in Revit a day, like spread out across 2,800 people, like that's, let's say each sync costs 10 minutes. Like that's a lot of time, which equates to a lot of money. Which is just like a really interesting kind of differing like logic set that I have to apply to this stuff.
John, do you have anything you want to share on the question? Because I do have a follow-up to this.
Yeah, I mean, I think I was at a firm that was obsessed with innovation, and it's really interesting. They used the university system, so they didn't pay for a lot of this stuff themselves. They actually had the people pay them to learn. So you had to do 3 years at Vienna before you could work at the office, right? Or there's a lot of companies that like, put their company right outside of Stanford, right? Because it's one of these places where they can just like use all of the innovation that's happening in the university system, like almost for free, right? And it just seems like it's just such a switch that instead of like companies like really like Saha had a research group, but it was really like their AADRL. And so they were just fueling all these people from the university that were just like, getting the research for free. It was kind of an interesting twist on it.
Yeah, that's definitely an interesting kind of aspect to this whole thing. So there's no question actually from the audience on the subject of R&D, how much money, and how much time usually firms you work at or you personally spend on. And I just want to kind of add another layer to that. It's like, because all of you have very, very different or very interesting backgrounds, not just from architecture and design, but also from, for example, computer science, structural engineering, or even painting, which I thought was very awesome. So I kind of want to ask, just was some of the like the mechanisms and also like the inner working of your everyday life, how you getting to help on a project as a designer or as a kind of a design like a computational specialist to solve a problem. Like how much time do you usually spend on the R&D? Do you do that independently on the side, or it's always kind of part of the project? And does the problem come to you, or you usually kind of are the kind of the vanguard or the pioneer that find the problem and come to solve it, and then kind of present it to the firm as a value add?
I think it goes. It's my experience is that it depends on the firm size, right? Some of these guys are pretty big. I was in a really big firm, so a lot of the work that I was doing at our studio and some of that, it was mostly supporting all these big projects everywhere in the world, right? Automating a lot of these processes, creating analysis models, getting those analysis models and put them back into a format that can be translated into coordination process and solving other problems. And aside of that, there was probably a 10-15% of R&D that was getting involved with. So I think it depends on the size of the firm. Now at SGG, I do a lot of more R&D and get involved with other teams, and usually I don't wait for them to tell me what or to expect for them to find, hey, we need this. You got to go and find it and get involved with the teams and understand what the needs are. Because if you wait, then it's too late. The project's already gone to a different stage, and you lose the interaction with the team and the needs. So you get to learn about what they want. And I think that's one of the things that you get with smaller firms. When you get something where you have a lot of different practices and different characteristics, like John was mentioning with Saha, it's very difficult. You have to spend a lot of time. There's a lot of needs, and it's too much. I think personally, I believe, I don't know if it drains you, but I think having a sense of you have to stop sometimes, tell them, hey, you know what, I can only spend this much time. I want to do this and follow some other R&D stuff. So I'm curious to see what other people say.
Yeah, I was going to answer in a bit of a smart-ass way, but I was going to say that it's either 0% spent on R&D or 100%, right? And I mean that because our R&D is spent on projects. So if we can find projects that are research focused, right, that may not necessarily be profitable, that's not the important part. The important part is that it's a project that'll make its way out into reality in some form, and there's some sort of business case that can be made for it. Then we'll devote all of our effort to it. We'll put people on it, and that's how Stereoform happened, the Chicago Biennial project, and that's how other projects at SOM at least happen. And that's great because architects, engineers, when we all work together, like the project is the best way to advance innovative ideas, because it's the mother, or necessity is the mother of innovation, right? And I totally believe in that. The problem with that sometimes is that it ends with the project. And so getting architects and small, large, medium scale firms, whatever, to think about ideas across multiple projects, for the ideas to kind of live beyond the projects, I wouldn't say it's a struggle, but it's not something that we're naturally incentivized to do, because we are we're service-based profession, right? And so that's kind of been my big push at SOM, as well as many others at SOM, is to try and carry threads of research across multiple projects and to kind of build the case for those ideas.
Yeah, I think you're 100% right in regards to it's either 0 or 100%. And I think at least at Perkins&Will, it's nice that we have we actually have a framework of research and development already in place that kind of allows for a level of incubation, even if it doesn't necessarily necessitate a kind of a business forward model to kind of research those things. And so we kind of handled it a little bit interestingly, where we have internal, we call them incubators. They're very similar to the hackathons that agents within Go-to-Go architecture have, except they're kind of distributed throughout each quarter. And of those incubators, there's a series of judges that essentially say this is something that is not necessarily valid, but it's interesting to kind of continue forward with this research. And they get kind of nominated to, they get a certain amount of funding and a certain amount of hours that they can dedicate to this project that they've proposed. And at the end of it, they present at the end of that quarter. But again, very much to your point, Kyle, like a lot of times that kind of research just kind of dies, right? Because it's not facilitated by a project. And I think those are the best kind of, or that's the best kind of research and development they can do, or ones that's kind of are like research and development that's specifically spawned by the project. But it's kind of difficult to kind of live in the dream world of constantly doing our R&D and also being billable, right? Like
so tough, yeah.
Yeah, we have to stay completely billable. I mean, we don't have any R&D money, so I feel like all this time is like a hobby for me. I do a lot of weekends, and like everything is project based, and I feel like the same thing that like you're talking about, going from project to project. It's definitely a problem. I'd like to see these longer threads. I guess that's just like inherent in the system, but we're all project based.
Yeah, and maybe to follow up with that, a question that we're getting here online was, really that to me, when you say that, like that, there's a lot of time spent after hours, or Mario and Aram, you're talking about like hackathons or incubators that are really like small sprints that are sort of tangent to projects. Like, do you think that those are supported, or threads that the firm also wants to, but does not know how to do? Or what's the, what's the reason that maybe that design innovation doesn't happen maybe on a project, or that you feel like that sometimes, this is all like extra because it's so far different than what the traditional path is of a project, that you kind of have to divert a little bit?
That's kind of an especially difficult question.
Well, no, I guess is it, I'm sure in some way all your firms support it, but is there like do you think that there's a recognition, say, on the leadership? Kyle, you were mentioning that there's a lot of people at SOM who are trying to get at this. Is this like something that is just it's a difficult nut to crack, or do you think that let's say Perkins&Will is like, okay, well, we have all these different divisions in these different research groups, and that's how we've decided to kind of understand or try to get this R&D, funded? Or in the end, I guess what I'm trying to say is computation in some way is making us sort of innovators within architecture and say market differentiators. And how is that being sort of recognized, supported? How can it be?
Right, and I think I kind of alluded to it in regards to the incubator. Like that is a corporately backed thing. Like there is money that is dumped into this kind of this program, right? And it's not just the incubator. There's also like there's another quarterly like research program that's kind of developed alongside the incubator, which is more to do with kind of materials research, right? Because we like have a large collective group of individuals who are very like from the top down, we're very kind of aware and interested in speccing like better materials for the environment, right? And a lot of that is like researching and understanding what these materials and what the kind of material properties actually mean for the environment and for ourselves. Like that's also part of it, a part of like research and development as well. And so like for Perkins&Will, like they do like for all intents and purposes put their money where their mouth is, right? Like they give funding, like direct funding, like here's money for you to figure this out. And they also give time, which I think is one of the most critical things, right? Like you're allotted, you're allowed to use, let's say 40 hours on this research project or on this incubator. And also, like it's seen as a kind of like, I mean, with all of this kind of research development and like talks of computational design, like I always think that there's like a segment to it that's like very heavily marketing focused, right? Like, and I'm not really sure like how I feel about that necessarily, because I feel like at least especially in the kind of like I don't know why I'm like making this a generational thing, but like I feel like the kind of the original progenitors of like computational design, like the frontiers people, right, of computational design, like they were constantly on this like, not only do I have to like design and deliver, but I have to prove to the people that like essentially like have hired me, or that you know that like that I work for, that like this is something that is that earns them money, right? Like, so like I would say that like that generation of computational designers like really had to be like both a marketer and like a very competent person in this capacity.
And when was that generation? Like what years do you think those?
I don't want to do that. I don't.
I remember reading a lot of these like computer papers, right? And then I look and they're published in the 70s, and I think, how far back am I going?
Oh, 100%. No, like like we are now like we're having this conversation, and it's just like I think we're all very well aware that like shape grammar was something from out of MIT from like the 60s, right? Like and like it's insane to us that like we're now just like, oh, we've just like crossed the depth and breadth of parametricism into like a brave new world. But it's just like, dude, like Archigram's been doing this weird stuff since like the 70s, like, and it's just more in line of like, it's, I don't know, like Revit is like 30 years old, right? Like it's in that same thing where I would argue that like architecture is actually like a very conservative like field, like, and it's very slow moving. It's almost sloth like, and that's the reason that we're having this conversation, or that I'm framing it in that way, right? Like, which I might be saying something that is a little like a hot button issue, but like, I don't know, we're slow. And I think we're some of the fastest people in the industry, because we see parallels to like why aren't we like there's so many different project management methods and like project delivery methods that are being used by like more and more technology firms that are proven methods. And like even this conversation is like 10 years old, right? But like, to date, I haven't witnessed an architecture firm that like fully like throws itself behind this sort of methodology, right? Like I'm still exchanging PDFs.
I want to throw something in here because I thought it's interesting discussion. Just we're kind of here leaving and just dreaming about COVID because all of this happened in 2020. And I feel like the reason why the architecture field hasn't changed much, maybe it's because the fundamental problem hasn't changed much. And now that we have COVID, it kind of changed a little bit. Like I saw a screenshot of, I think it's Mario's screenshot of a social distancing tool that's being developed. And I wonder if, maybe the social distancing as a new kind of totally new design problem came from nowhere, becomes a catalyst for us to do something different, because now that it's on our mind, it's on the client's mind, it's on the public's mind. I just want to throw that as an example. Maybe there's something there. What do you guys think?
So I have another hot take. I think the whole like 6-foot social distancing thing was like very reactionary, which like speaks very much to like the kind of practice of architecture right now, right? Where a lot of it is reactionary, not like preemptive. And I don't know, when I thought of it, when I was like integrated into this thing and like, oh, let's develop like a 6-foot social distancing thing. Like I thought it was cool because it's an interesting kind of task and something like to take my mind off of certain things, oddly enough. But like in my mind, it's like, it's not like, how does 6-foot social distancing change things? It's how what are the ramifications in society and how we experience architecture outside of the pandemic, right? After this, right? It's like, what does that mean for architecture? Like, is it going to be like more joyful, or like our interior is going to be more lavish, and like, because like those are causes for celebration, and like, how do you, like, there's a lot of like different like weird sociological like impacts on that. But I guess within the framework of computation, that's a really hard thing for me to figure out, right? Like, it's just a difficult thing.
Yeah, but just following up from the previous discussion, it's like architecture is very conservative, and the technology was, very much not, it's a slow moving ship, but all of a sudden, almost or just over a year ago, we all went to, remote work, and all of a sudden technologies that were pipe dreams when we were talking in these groups are all of a sudden at the forefront of internal discussions and discussions with clients. And I think, I'm curious as to you guys' experience and to, I guess, just pile on that discussion.
Yeah, there's a lot of questions floating around right now. I hope I think it's my contrarian take to this question is just that I hope nothing really comes out of this other than we're all a bit more comfortable working remotely and we have more of these conversations. And also we have a few more indoor-outdoor spaces in our buildings and they're a little bit less monolithic. But I will say more broadly, and to go back to kind of answering, I think a statement that Mario kind of made earlier, it's like, you cannot, I think the contemporary thing to say now in computation is that research is not computational design, right? Or applied research is not computational design. Computational design is not applied research. And that's important because, a lot of the people at least at SOM that have become very successful and have become leaders were definitely researchers, right? And I think a lot of people will come out of this period being researchers of a new form, right? And will become successful because of that. But I think, the more we can move to just sort of seeing ourselves as a medium and not so much as an independent research topic, the more we can kind of normalize our work. And, I don't know if that makes sense, but.
Yeah, no,
I would add one thing that the COVID stuff. We had a conversation with a few at SGG and other parties outside of SGG, and I think the most interesting thing about this is not these like 6 feet tools, but I think other tools that enable IoT and digital twins and SaaS, services as a software companies that are delivering these other things that are part of the built environment. I think for me that's a little more interesting. How do you retrofit buildings to accommodate for all these things, right? What's the HVAC look like? What does the elevator look like? What does the entry point to the building look like? How do these technologies with phone and tracking and all these things become more, kind of like elements of the design, and how do they become part of the urban planning? So I think that for me, it's something that's had an impact, and had an impact of developing also web applications that can, view models and coordinate models, and that exploded. There's a bunch of companies doing that, and WebGL and all those things. So I think those are the most interesting things that come out to some degree. But this pandemic is going to go away, and we're all going to come back to the same, office space, and then it's going to happen again sometime soon, and things will have to change. But that's what I think it changed most.
And maybe, as we're kind of winding down here on time, maybe that's a good segue into, maybe speaking about sort of speculation about the future. Again, I think it's great that all of a sudden, what is this 10-year conversation all of a sudden gets summed up in a year, and we get asked a lot of questions now regarding these topics. Are there topics or technologies or different applications of computation that you're that you're looking towards in the future?
Somebody wrote a question about NFTs.
Yeah, computer I was laughing about this.
I don't know, man. Mark Foster Gage just NFT'd like
$500,000. I was like, whoa.
Is it really?
Yeah.
Oh my god! It's not even a model. It's like
more than 10 people who are buying NFTs. That's what I want.
Oh my god, dude! seriously, sorry, I didn't mean to that was like a throwing a dynamite stick in this conversation. Yeah, no, I mean, not to be like the dork about this, but like blockchaining is a really interesting thing, right? It's just a way of like essentially opening up contractual obligations, right? I think that's interesting in regards to like the architect fabricator contractor relationship. I think being able to be really open about that, or allowing, like Shop did it like how many years ago, right? Like they integrated like the conception, not them, but like they made popular the conception of like sweat equity, right? Like I'm going to just input my labor and I will get a part of this development, and however successful it is because of whatever it is that I have engaged in, I get a share of it. Like I think that's something that's a really interesting kind of mode of operation that's made possible by blockchain. Right. Or by integrating blockchaining within the kind of contract. That's kind of boring though, right? Like it's like, but I think it's interesting.
Blockchain, yeah. I think web. I'm more interested in right now. It's cloud-based performance cloud solutions in the cloud, and delivering this process in bringing that into the design environment. I think that's something that's interesting right now.
Yeah, design interfaces in the web. I still feel like when you see a design interface in the web, even if it's like a little thing that allows you to draw a plan or something like that, you're still, even us, like maybe just me, but you're still kind of taken aback by it and wowed by it. And I think it's the kind of accessibility and network effects that are kind of packaged up in that beautiful little interface that allows you to draw in a browser. So I'm super excited about that. I'm also in terms of like digital design computation, where should we go? I'm firmly in the camp that we should be focusing on urban design, just because I think large data sets, they can only go so far on a building in terms of making a big difference. Like oftentimes they get driven in very aesthetic directions, and I'm totally there for that. But I think where large data and kind of large manipulation of geometry and analysis can really be impactful is obviously at the urban scale, and it doesn't seem like, I mean, there's a lot out there, and I know that speakers have spoke here about that, but I think it's nascent. I think we have a lot of opportunity there.
I think I spend all my hobby time doing like machine learning. So we're trying to get these big data sets. We're trying to apply them, and I think I showed a little project where I applied that to kind of a painting, but I think if we could just move the step beyond image-based, and move machine learning into a CAD environment, I would be super excited. That's what I'm after.
Yeah, AI definitely is a hot topic for quite a while. I think there are different kind of people coming from it from different angles. I guess I have a question related to that. Is the topic of data, just the nature of the way that we practice. We are project based, like we go over that already, and the nature of a project based means that's going to be like one off. And how do we, like, in order to really kind of take advantage of, for example, big data or artificial intelligence, what do you imagine could happen in the future, in a way, post-COVID or digitalized living environment that we as a designer can actually get access to big amount of data to actually make a difference, or utilize it on some kind of computational tool? Or like, do you think there will be a change in the way that we do design, or the way that we engage with clients, or do you think there will be a different things that we actually design for, so not just architecture? This is kind of me speculating.
I think so. I mean, I think there's different ways that you can do it, especially in urban planning. I think there's sidewalk labs just come out with a platform. RGS has machine learning algorithms that allow you to speculate on the design and metadata on it. So I think we play with some machine learning in-house, or look at some plugins that allows you to do some of these things. But I don't know. I think it's too early to say. I think the metadata allows you to identify items or processes that allows you to give you informed decisions early on. I think those are the most valuable. Not solely not designing the whole thing or making a design move yet, but I think just informing the stakeholders. I think that's at this stage. I think that's more valuable to me.
I think from like the opposite, like super more boring end again, because like I'm like almost fantasize, like I fantasize about like optimization as much as possible. Like I don't know, for me it's like the amount of like PDF pages that I see go in a set is like astounding when you compare it to a set from like the 60s. Like I don't know, like how much did the IBM tower use for its set? I think it's something like 100 and some odd pages for the whole tower, like all of it. And I compare it to like like one of our modern sets, and it's like well over 1,000 pages. And it's just like over detailing, right? And I think we're kind of working on a kind of project right now that uses a bit of AI, and we're leveraging some ML to like figure out how we can essentially reduce documentation, and how you can start. I mean, very dumbly, like auto tag like documentation as well, right? Because that drives the amount of hours. How long have you spent like tagging like a section or like a plan or like, you know, any of that stuff within like whatever documentation tool that you've used, when like you've already kind of like integrated a bunch of metadata into the thing, right? Like that's always been like the dream of BIM, right? Which hasn't like lived up to its name in any capacity other than like, okay, you've like successfully created a massive data set that like basically no one can navigate. And so like, I think that's also another thing, right? Is like data optimization in regards to like how like it goes back to like what I consider like digital craft, right? Like it's data optimization in regards to like what we actually need to produce to like get this thing built, right? Because at the end of the day, that's the real thing. That's the like that's the VIG, right? Is getting something built, and what's the minimum amount of data that you need to get that thing built. And I think that's the kind of potential future is like, I don't know, here's this 128 kilobyte JSON file. That's the whole project. Like, because it's just work planes, data points, and kind of material, or like not like spec like callbacks, right? Like, I think that's super interesting.
Yeah, I think you touched on something that been joked about in the field for a long time. Like, are we drafting in the digital space, or are we digitalizing our design process? It's two different things. Like, it looks similar from the outside sometimes.
Right.
I do think data will be used or as it's used more at the urban scale. I mean, Hiram, you mentioned sidewalk labs. I mean, once that starts to become more mature, I think there'll be a lot more prescription of buildings at the zoning level. And so maybe as architects, we may have less agency in design. I don't know, or maybe we'll have more, but building or cities, municipalities, codes, they'll become more prescriptive as we have to deal with densification and materialization and carbonization and all of those. And so I do think that, as designers, looking at the urban scale, looking at how we can leverage data to understand design and its impacts is going to have a knock-on effect on us as architects, at the end of that process.
I think what's really funny about this question about documentation, like, is how we approach it, and it seems like we're approaching it kind of traditionally. Because when I look at Google Maps, like they've documented the whole world, right? And there's just a really clear system of you take each level of zoom and multiply it by 2, right? And you take this effort, you take the system and apply it like all the way down to 21 levels of zoom, and then you've got the whole world, right? So why are we still making scope boxes on sheets? Like who cares about a blank sheet, if you've got a system that documents the entire world?
Mm-hmm.
That's the like conservative part of our
because the title block, John, the title block.
Well, a lot of that also has to do with it's not just how we do things, also how our contractor, how our consultants do things, how the city approves things. And, It's not just design; it's also a legal process and a political process and a communication process. That's, I think that all of that will have to come into this discussion.
When you get a contractor that can get JSON files for construction, let me know.
What happened when you actually have really capable 3D printers? Maybe that also changed things.
Yeah.
So out there. Like, what if you're actually building things on Mars? Then you probably require different kinds of documentation.
It's definitely a different shadow block.
Yeah.
It's more curvy.
Exactly.
Shoot the code. Just shoot the code and make it start making it.
Anyway.
Great. Well, I mean, just as a wrap up, I think, because we're about at time now, but I think that was a great point of to wrap up on, because I think what's really encouraging, and maybe where I don't share the pessimism of like this is a 10-year too late conversation. I think to propel us forward to the next 10 years, I think tools like what you're talking about need to become more pervasive within our offices, and you guys are definitely at the vanguard of that. So I hope that it's definitely just a precursor to something that's going to happen in the next 10 years. So thank you guys again for a great discussion here, and giving us the insights into your background and your process, and thanks to everybody on the YouTube stream who was watching, and we will keep you notified for the next installment.
Yeah, thanks for having me. It was fun.
Yeah.
Thank you, everyone.
Thanks.
Appreciate it.
Definitely looking forward to seeing you all next week. Bye. Bye.